Hello and welcome back to the lab. Today we have a box that's traveled halfway around the world to be here. Patreon reached out and was struggling with a device which will be in this box and asked if I'd be willing to take a look at it, see if I could help him get it off the ground, get it running. I said yes, and this spent the last week and a half in the airmail. So it was a week and a half in airmail. That'll tell you how far this thing has traveled. So what we're going to do is I'm going to pull this out of the box. If I remember correctly, there's also a donation for the lab in this box, as well as the device that needs assistance. So I'll get this open, we'll get this on the bench, and we'll see if we can't help out another technician. And this is the package I thought it was. What was in the box is now out of the box. This is these are two TM500 plugins. One is sick. They are both old. I'm seeing things I don't like already. Some potential places where this is sick. I am seeing TI sockets. Yes, this is the one that is ill and needs assistance. We have a TG501 module, and the other unit, which is the donation for the lab, is probably, since these things usually get loaded into a frame at the same time, along the same vintage of age, it is. We have the brown circuit board with the gold traces, which means it is of older. Actually, it's in really, really good shape, and I haven't seen this color pattern before. This is the donation for the lab. This is another AM502. Let's see, these were last looked at NIST traceable cal in '98. So, fairly good usage. Interesting label. So yeah, the TG501 is the one that is the SICK plugin that we're going to take a look at, see if we can't get up and running. And the AM502 is a differential amplifier for the lab, so that'll be another video. But for now, let's see if we can't get this time mark generator working. I don't know much about this one. All I know is that supposedly it doesn't work. So I've got my known good power supply. I've got the unit. Need a power cord. Took me a minute to find one. They're everywhere until you need one, and then they're nowhere. So we'll get that hooked up into there. We'll get that hooked up here. Get a coax line and a 50 ohm terminator, because these time mark generators go very squirrely if they're not terminated. For those new to time mark generators, this is the main output. This is the output for 1 nanosecond time marks only. You only get 1 nanosecond time marks if one of these buttons is pushed in. And you only get the 1 nanosecond time marks if it's on the blue with the 1 nanosecond pushed in. That means it's here. Output for 2 nanoseconds and 5 nanoseconds will be here. Also, if you're looking at one of these and you don't have a fast scope, 1 nanosecond time marks is a 1 gigahertz signal, so it's usually too fast for most scopes. What I got to do in the lab to get 1 nanosecond time marks is I need to go up to the DSA 602. the 7854. The 7603 is 100 megahertz, 7854 is 400 megahertz, and the Rigol is 100 megahertz. So can't even catch the 1 nanosecond time marks. So we're going to be in the main input. And let's do something respectable. I have no idea what's wrong with this. All I know is a switch cleaning has been attempted, and when it went back together, it wasn't working right. So you now know as much as I do, but we'll see what we can do to get it off the ground. I've got the Rigol set up. 1 volt per division with a 1x probe. Measurement is off. We'll turn the counter on. All right, let's see what we get. That tried for a second. Something smells a little warm. Try turning it on again. Let me move you guys over to the scope, see what I saw. Sorry about the shaky cam. The glare was horrific. This was a single shot capture that I did when I was turning the unit on. This does go away very quickly, but this does mean that it's trying to work. So we do have some signs of life, so this is good. Well, this just became an interesting repair. This is the waveform I'm looking at, and if I stretch it out, we can see time marks, but then they're getting bigger, and then they're falling, and then bigger and falling. So this is a very odd waveform for when the unit's on. So this one's going to be interesting. Let's open it up, take a look and see what's inside. Okay, I have replaced the socket on the suspected bad IC. Here's the IC and the very crappy Texas Instruments sockets. These are old. They don't make these like this anymore, thank God. These are those really, really awful side-grabbing sockets that they did back in the day. So they're out. We have a new set of, what are these? These are SN4000Ns that we're going to get installed. So we'll drop these in, and then we'll give it a test. Okay, well, I need to order a bit more parts. Ran into, thought it may have been the crystal. I will get the schematic and kind of explain what I'm fighting with when I get this all figured out and squared away. We've got the new socket in, and I've got the new IC in. Didn't make a change. Thought it may have been the crystal, but crystals very, very rarely go bad. Doesn't look like it's the crystal. I tested the crystal using one of my function generators, and it's resonating like it's supposed to. It is a little noisy. Like it's not as locked in as I'd like it to be, but it could also be the age of the crystal, things like that. So I also found in the oscillator circuit there's this resistor that is out of spec and out of tolerance. Not by much. The specification of the resistor is 300 ohm, 5%. This is measuring 320, so it's, I mean, it's out by 5 ohms. Normally I wouldn't mind a value like that, but with this being the actually in the oscillator circuit and part of the heart of the oscillator, it might be enough. I don't know. So I'm going to order a 1 megahertz crystal, and I'm going to order a another 300 ohm resistor, and we will see what happens. I checked my stock of resistors, and lo and behold, the value that I need is not there. Of course, I have all kinds of 3.3K, 330 ohm, all kinds of stuff. I don't have any 300 ohm. So we'll get a resistor and see if we can't make this thing kick over and sing. This oscillator's buffered, so there's nothing further down the circuit that's grounding it out or anything like that. It's just, I'm sure if I could sort out why this oscillator's not kicking over, I'll get the whole thing to start and it'll be fine. But I gotta get the oscillator kicked over. So deeper down the rabbit hole we go. Well, one of these things is not like the other, and it's this one's been driving me nuts. I checked most of the parts in the oscillator section. I even did some leakage testing on the ceramic capacitors, thinking they might be toast. And it looks like I may have been looking at an elephant with a microscope. So on the bottom is my unit that's in the lab that I did a previous video on that is fully functional. This is the unit that's not running. And it's been driving me bonkers because if I compare readings between the two units, everything's coming out in spec, everything's testing good, everything's weird. Did some power rail measurements on it, and it turns out the 5-volt rail for the oscillator is at 4.8 volts. Barely enough to run a TTL chip. Wasn't too happy with that. Usually there is a 5-volt adjust on these units. There's not. And that's actually where, so I went deeper into the schematic, into the power supply, and I'll get the schematics and go over this here in a little bit if that's of interest to everybody. Towards the end of this video, I'll pull out the schematics and kind of go through my thought process and where we've been going at. This is the one that works. There's a potentiometer right here that's missing from up here. So it turns out, and this kind of looks like a bodge, but it's not. It's from the factory. This is a this has a Tektronix part number on it and everything. So this is actually a modification. This is a 15-volt rail adjust. This doesn't have any rail adjustments on it whatsoever. So I checked the 15-volt rail on the unit that's being problematic. The 15-volt rail is running about a volt low. It's running 14.1. So that's going to cause some problems. But the 15-volt rail is also part of the reference for the 5-volt rail. So the 15-volt rail being down a volt would explain why the 5-volt rail is down 2 volts, or 0.2 volts, which could potentially push my oscillator into not starting. Because the main problem with this unit is the main oscillator is not starting. Everything works. It's just the main clock isn't running. Now, the main clock on this unit is dirt simple. It's a ring oscillator stabilized by a crystal. I even checked the crystal. So the crystal's resonating at 1 megahertz just like it's supposed to. So this one's been a headache. But I think what I need to do is, this is a factory modification, and if you look at the serial numbers, this is mine, B010167. This is actually an older unit, B030, wait a second. No, this is even a newer unit. Yeah, this is an even newer unit. This is a whole bunch newer, so I don't know if that potentiometer was a the factory found out, oh, this is a problem, and they had to put that in. Traces are cut on the board, so it's definitely a permanent modification, but it does look like it's a and the schematic shows a pot there. So the pot should be there. It's not. But this also doesn't have the trace. The trace is cut. So I think this is a factory unit that nobody's been in before. This particular unit has had a factory modification put in, which Tech did a lot. So I'm going to ask some questions on the internet, see what happens, but that's where we're at. Okay. Well, Turns out the FedEx guy came in and delivered on a Sunday, which was very impressive. So thank you for them. And so the pots came in to add R600. These are, the manual calls for a 700K pot, and these are 1Ks because I couldn't get a 750. Sorry, 750K pot. These are 1Ks, couldn't get a 750. But these are 4-turn potentiometers. These are 4-turn potentiometers, so they'll have a good enough adjustment, and we'll be able to dial it in pretty good. This is the unit that works on top. This is the potentiometer we're going to be adding. So we have to do some modification to the board traces and get those out of there. I'm also going to take the top cover off of that one to just verify that I don't need to change out any resistors or anything like that on some other components. So I spoke with the owner of the unit, and he said go ahead and do the modification. So we have to destroy some traces to make room for the potentiometer. And the traces of interest are these two right here. These need to go away, or this jumper link needs to go away. And this trace going down to the base of this transistor, these 3 pins are a transistor in the 15-volt drive circuit. That needs to go away. So I need to break this trace, and I need to break that trace. And then the potentiometer is going to go on this pin, and this pin. So I'm also going to check and see if any resistors on the other side of the board need to be changed. But we're going to go ahead and cut the traces. Like so. And I'll do that with the other one. And now we'll just get these breaks out, and then I'll bring everybody back. That PCB grinder that I found would have been real nice. I may have to pick up one of those if I ever have to do this modification again. We have the trace cut here, and I've also have the trace broken here. I've checked there's no continuity between here and here and here and here, and I took a soldering iron and heated up the board and just pulled the trace off where I cut it to make sure that break will stay permanent. So now I need to bend some legs out on the potentiometer and get it installed. Okay, I'll use the small fluke meter because I can get it into the camera shot. But what we'll do is we will put this here. We're on DC volts. I did check the potentiometer just goes to a resistor to ground, so the fact that it's a 1K isn't going to matter. I just triple checked that because I checked it when I bought it. But here is our 15-volt test point here. And we'll turn on the fixture. And there's 14 volts. But this should actually be adjustable now. It is. Look at that. All right, we can get it to 15. So, yeah, 15.7. Perfect. Had a weak ground here. That's better. So, I can now dial a voltage. So let me get the whole thing put back together. See if it actually decides to go. Let's see. I think, if I remember correctly, this is the 5 volt. Hey, look at that, 515. All right. So our rails are back. So this oscillator section has been driving me nuts trying to get the oscillator running. It's just not going. Voltage on the pin 6 sits about 3.5, 4 volts, and it's driving me bonkers. So at the moment, the crystal's out, So I'm just trying to get the single oscillator section to fire off. Started disconnecting things just to see if I can get the oscillator running. And then I was going to build back up from there and find some faults, things like that. And I've got this resistor out of circuit right here. There's another resistor that sits in right here. So just trying to get the IC to oscillate. And I get to this resistor and I desolder it, and look at this. Look at the solder ball. It came off. That came off the resistor. That could have very well been shorting to something and causing some problems. So let me get this cleaned up. I'll get this resistor measured. If it measures good, I'll put it back in circuit, and then we'll see if it doesn't run. Well, after being on the bench for a while and trying a whole bunch, this one, for right now, has actually beat me. But this unit has more problems than just the clock oscillator. So this unit's actually... Physically, this unit is in very nice shape. Electrically, this unit's a mess. So what I've got going on right now, I've got 1 megahertz coming from the function generator down into these wires right here. I'm watching the function generator on the frequency counter, and I'm watching the function generator on the, or I'm watching the unit and the function generator on the scope. Let me move over to the scope real quick. So what you can see in the scope is the yellow is the time marks. Let me turn off purple. Yellow is the time marks. They fall out and then come back, and then fall out and come back. Okay, maybe there's a little bit of oddities going on. This is 500 microseconds per division, and I'm getting a 2 kilohertz time marks out of it. I have the time mark set to 20 microseconds, or 20 milliseconds per division. So I'm getting 500 microsecond, is it, yeah, 20 milliseconds. So I'm getting 500 microsecond time marks. It's actually way too fast. Yeah, so the oscillator is at 20 milliseconds per division, and it's running at 500 microseconds per division. So it's running way fast when it's set to the correct reference. So there's something else wrong in the division circuits and things like that. I'm going to grab a schematic, and I will go in depth into this crystal reference. Okay, this is, for those who are interested, here's a deep dive into the 1 megahertz reference oscillator for one of these TG501s. These are, this is what's been driving me nuts for the last couple of days. This section right here is the oscillator itself. So it's pretty straightforward. These are not inverters. This is a 74L00, so these are actually NAND gates. But on the circuit board, they have the input pins tied together to make them look like inverters. So schematically, they're inverters, but they did not use inverters for this IC. If you disconnect, this is the crystal here. If you disconnect the crystal right here, this should self-oscillate just by itself, just with the gate, the resistor, and into the input pins. This should buzz just by itself. The new chip, the new chips that I got, the brand new ones, this does. If I tie the gate and put a little bit of resistance in there, I get a decent, almost sinusoidal waveform. It's kind of distorted, but it buzzes at 67 megahertz. So it's screaming pretty good. But so it's stabilized by the crystal, which is here. Then it comes down into this gate, which also inverts, then back feeds into here. So these things should bounce back and forth, being stabilized by the crystal, which is oscillating. And then we have a tuning capacitor here, and then we have some capacitance to ensure it starts. I have fought with this oscillator for 4 days trying to get this thing to start when it was on the board. If I breadboarded this up, if I did everything else, this thing would buzz like crazy. I could not get this thing to buzz when it was on the circuit board at all. So it was very strange. It just wouldn't go. This is not a very good way to build an oscillator because they don't. At the time, it was all we had. However, Schmidt triggers would be better because of some triggering and things like that. Gates don't like to sit at a specific. Gates don't like to sit halfway in between their switching voltage. The output of this, if I measure it on the scope, just hangs at 3.6 volts. Not enough to trigger the gate, but not because if it triggered the gate, it would drive low and it would start self-oscillating. But it just hangs up at 6.3 volts and doesn't do anything. The last experiment, which you just saw, was me thinking we could drive it from an external oscillator. I was thinking about doing a complete redesign of this circuit and essentially making an oscillator that would fit in that plug. That didn't work. And then the other gates in the package just buffer the output to hit this AND gate, and out it goes. Because what happens is this oscillates, it's buffered twice, the AND gate goes, and then it goes out into the rest of the circuit, or into the rest of the unit, and then it's just frequency division and multiplication from there. If this is a topic of interest, I could definitely do some things on a breadboard. I could make a video on this about these self-oscillating circuits and kind of tuning them a little bit and using the crystals and things like that. I even checked the crystal as to if it was good or bad. The crystal's fine. At least it pops its voltage at 1 megahertz, which is what it's supposed to do. So for right now, this one's beating me. I'm not sure where to go from here. But I have a sneaking suspicion after the test that I just did that there's other frequency problems further down in the chain with some of the divide circuitry, because it does appear, actually it'd be the multiply, because it does appear it's being slow, I think, if I remember correctly. I have exhaustively checked every single component in the main reference oscillator section, aside from that one bad capacitor that was mildly shorted. Nothing's bad. Everything works. So it's been driving me bonkers. I replaced the socket. I've checked the resistors, checked the capacitors. Everything checks. The only resistor that's mildly out of tolerance is R108, and it's about 30 ohms high. But it's just a resistor going from pin 3 of U100 into pin 12 and 13 of U100. So all it is a buffering resistor. So it's not, that's not causing it not to wiggle. But yeah, the crystal's good. The IC is good. I replaced it with an IC. The IC that was in there was faulty. Even if I inject main oscillator signal on pin 8, which is the output of the socket, into the rest of the circuit, it still doesn't function right. The waveform, the timing is way off. It collapses. It's not working correctly. There's actually 2 oscillators in this circuit. They're compared in U320. No, 230. U230. The main 1 megahertz reference oscillator is compared to the 100 megahertz oscillator, which is the VCO, and it's that's how it adjusts the frequency to keep it on frequency. After thinking about this for a couple of days, I'm starting to think the 100 megahertz VCO is having a problem. So we're going to check the 100 megahertz VCO. That's why I brought the scope down here. I've got 1 megahertz that we can put in for the reference, but I have a sneaking suspicion it's going to cause some other problems. So we have We have some additional issues in the circuit that need to be figured out. The output's collapsing. It's running, I'm getting time marks, but then it falls apart, then it comes back, then it falls apart, then it comes back, then it falls apart, then it comes back. There is a lockout circuit in a TG501 or TG501 that if the PLL loses lock, it drops the output out. So what I'm thinking is happening is I'm seeing what the circuit is thinking is bouncing in and out of lock, in and out of lock, even though it's not locking, and it's not locking correctly because the output frequency is off by more than a factor of 10. So we have some oscillator problems, we have some division problems, we have some other problems. It's got problems. So hopefully this can be a troubleshooting video, and we'll get into it, see what we can figure out, see what we can do. I'd love to get this working again, especially with the variable capacitor being terminal. I'm not sure. I'm going to have to redesign the 1 megahertz reference because of delays and things like that. It's not quite 1 megahertz. It's a little bit off, and that's how they're lining up the frequency. So I need something adjustable in the 1 megahertz oscillator. So just putting in a 1 megahertz reference isn't going to help. I need it to be slightly adjustable to dial in the frequency. So that's where we're at. I'm going to let the scope warm up. I'm going to let this unit warm up, and then I'm going to see what we can do for if we can find the 100 megahertz clock and look and see what that's doing, because that's the next step in trying to get this thing resolved. All right, so here's our 100 meg reference oscillator. Here's the 1 megahertz. Here's the 100 megahertz. I'm really interested in what's happening at U290D, which is pin 11 and 12. Those are the outputs of the buffer for the 100 megahertz VCO. So let's probe those two locations and see what's going on. That's going to give us a big clue as to the health of this 100 megahertz reference oscillator. So we'll check that. Okay, U290 is going to be fun to probe. U290 is all the way over here, so I think what I'm going to do is I'm going to flip it over. It'll be easier to get at it from the other side, so let me flip it back over. But pin 1 is up towards the front. So we have 8, 9, 10, 11, 12, so these two pins. So I'm really interested to see what's going on right here. So now this is going to push the scope to its limits, because this is only a 100 megahertz scope and it's a 100 megahertz oscillator, but the scope will at least tell me if it's running. We are on 10x probing. 1, 2, 3, 4. Get a little bit of something that looks like it might be. Actually, that's saying it's 9 and 15. And it's 13 on the input, so let's try that. So that's 13 on the input. That's 15. That's doing something, but I'm not sure I'd call it triggering. Okay, here's a single shot capture of what's coming out on pin 9 of that IC. We do have what looks like a little bit of oscillations, but it's very weak. 100 millivolts with a large DC offset, and it's only 7.4 megahertz is what the frequency counter is picking up. So we're way off of our 100 megahertz that we need. So here's the oscillator for, this is on pin 13, so we are getting oscillation. I don't know if it's enough. because I'm 20 millivolts per division, but I'm at almost a 400 millivolt offset on pin 3, so I have the trace brought down by 400 millivolts, and I'm still only getting 7 megahertz, 7.5. Okay, so in giving the unit a 1 megahertz clock, we definitely cleaned up the VCO. This is on pin 13 on the input. It's not stable, but my internal crystal clock isn't stable either. So it's not surprising that it's jumping around like it's 100.17. Let's see. See, it's not stable, but if I single shot capture it, 100.179. So it's pretty stable at 101.79. So now the question is, what's at 11 and 12? Because if that's at 13, we need to check at what's on 11 and 12 and go from there. Okay, we do have some signal. However, it's only 92.25 megahertz. So that should be the same. It looks like. I got to look up what U290 is. See what those pins are supposed to be. Misread the schematic. It should be pin 15. Yeah, that is 100 megahertz. Okay, so we are running at 100 megahertz. Okay, so let's see what U310 does. Okay, that comes out this way into a divide by, upside down. Comes out this way into a divide by 5. So our output of the divide by 5 is U315A, pin 2. Now I gotta find 315A. Okay, 315 is gonna be this IC right here. Move my clock. This IC right here. So let's check pin 2. See what we have there. We should have 100 megahertz divided by 5 if everything is working correctly. Okay, here's the output of 315A pin 2. We should have 100 megahertz divided by 5. We do. So we have 20 megahertz here, so that is working. We're on a 10x probe, making sure, because we're on 500 millivolts per division, so our peak to peak is not that high. It's 1.6 volts. But it is dividing, so we're still there, we're still divided down, and we still have activity. So it looks like at least that clock is working. Let me check the, let me get back into the documentation and find out where the out of lock fallout is. I wanna look at this right here, this out of lock detector, and see what's going on. The out of lock detector goes to S350. And it goes to schematic 4 and 5. All right, well, we made progress because I got everything reassembled, got it all put back, and my waveform's not collapsing anymore, just the timing's off. So I know the 100 megahertz oscillator is working. This seems to be working well. But it's also saying that it's locked. So this now leads me from a timing problem into the decade divisions and the switch. So the division, so I need to check the division circuits and see what makes sense where and what's going on. But at least it's stable, and the time marks look good. I mean, the actual time marks themselves look to be very healthy. The problem is I have the unit set to 1 microsecond time marks, and I'm getting, wrong knob, 200 microsecond time marks. So what should be a 1 megahertz is running slow, very slow. I'm also not worried about overall stability because I'm feeding the main clock with my function generator, and that doesn't have the best reference in the world. So frequency-wise, if it was bouncing just this least significant digit, wouldn't care. But it's off by several orders of magnitude, so I have a sneaking suspicion I either have a problem in the switch or I have a problem in the decade division. But it looks a lot healthier than before. Okay, this makes sense now. One of the decade counters is bad because if I'm going to revisit the circuitry, but I think they're doing the frequency division with counts, and with them doing the frequency divisions with counts, when the error comes by, we're seeing the error sweep across the scope. So if I slow this down even more, actually you can't see it that well. There's the error. Triggering, everything's stable, there's the error. And it's only happening at certain settings of the clock. So if I go to So if I go to 1 microsecond, it's not glitching out. If I go to 2 microseconds, now I can't lock. There, it's acting weird. But 1 microseconds, but there's 0.2, so it goes crazy. But at 1 mic, it's fine. But there, oh, nope, that one went. That should be 50 millisecond time marks, and it just goes. I wonder if this knob's off, if it's slipped on the shaft. That would be an elephant with a microscope moment if the knob slipped on the shaft. Because that would be 200 microsecond time marks. That would put it off by 2 positions. Let's see if the next one down actually is 0.1. It is. The knob's off by 2 positions. I still have to figure that out, but yeah, the knob's off by 2 positions. Chalk it up to one more thing that's weird about this TG501. Ay, ay, ay. All right, let me get the knob repositioned, and then I can confirm that by trying the fastest. Actually, I should hit the fastest ones if I'm off by 2. Yeah, that should be 0.1. And that's working. Okay, so knob's off by 2 positions, and I have a bad counter somewhere. Lots of progress. Okay, now that the gear's warmed up and the frequency counter's a little bit more stable, I can actually get the frequency got a lot better. I've got 3 zeros, 4 zeros, but we're running about 20-ish hertz high. It's bouncing up and down, so that's not too bad. But I have it set to 0.5. It's at 100. So what we need to do is we need to move it to well, now I don't know if it's off. Let's see what it does at 5 seconds. I'll be back when it draws the waveform. Yeah, this is off by several orders of magnitude. I have it set to 0.2 microseconds, and I'm getting 200. I'm sorry, I have it set to 0.2 seconds, and I'm getting 200 microsecond periods. 100 microseconds. 50 microseconds doesn't even give me anything. That might be a clue. Um, 20 microseconds. Yeah, I think we have a dead counter in the decade counter. Let me look at the schematic for the decade counter, and I'll be right back. Okay, so here's where we're at with the very ill TG501. I've got everything kind of working with it, except for it going crazy on the dial. So I'm getting good time marks. When everything's locked in, it's stable. Obviously, we need to take care of the reference, but on the dial, 2 microseconds, 1 microsecond, 0.5 microseconds are correct. All the other ranges are messed up. So that points me to some of these ICs right here that I'm probably going to have some failed gates in here. So we should be able to narrow this down, even if I have to exhaustively test every gate that's in here. should be able to narrow this down to which ICs were bad. My suspects at the moment are U330 and U300. Those are the two ICs that I have questions about, because those are used in those ranges where they're working correctly. So if one of the gates is stuck and it's not switching like it's supposed to, and it's staying high or staying low, whichever the logic value is supposed to be, it'll cause the whole thing to go out to lunch because it's getting the wrong signals. So that's going to be my next check. So what I'm going to do is, because this is starting to become a much more in-depth restoration than I was expecting, I'm going to cut it here. But we are going to continue working on this. We're going to see if we can't get this working for the person. If this does end up not working, we've got some options there too. But given where we're at right now, a little more time, I'm pretty confident we can get this thing brought back to life so it's making time marks again. But that is where we are at. There's a bad connection. The scope just went kind of... Yeah. When I bumped it, it destabilized, but then it stabilized again. So if I have to change out any of these ICs, this does have the TI sockets, they will go. So if any of these ICs have to come out and they're bad, the TI socket's going with it. I've got a good desoldering tool. It's not going to be a problem. So that's where we're at. I will we'll get working on this, see what we can come up with, and I'll actually get a breadboard down and we'll test some ICs. Thanks for stopping by the lab, taking a look at part 1 of this very sick TG501. Stay tuned for part 2, where we do a deep dive into the switch section and see what we find. I'm thinking right now, unless something else weird happens, we may have squared it away. At least we know the direction to go in, but won't know that for sure until I actually get the troubleshooting done. But I am hopeful we'll be able to make this one function again. So thanks for stopping by, and I will see everybody in the next video.